years in the software development and project implementation, and is currently working as an associate director for the machine learning and deep learning projects in a company. And he possessed the experience in IT industry, focusing on business analysis, designing, development, implementation, and migration of large-scale projects. And he has a great knowledge on algorithms, data applications, data structures, binary, artificial intelligence, machine learning, deep learning, and all sorts of things. So, sir, I will hand over the class to you.
Sure. Thank you very much. Thank you, class, for joining today's call. It was great pleasure to have you here on the class. Okay, so let me start sharing my screen. Do let me know if you can see. Can you see my screen?
Yes.
Yes.
All right, good. Okay. So again, welcome to next exciting journey in machine learning area. Going on the next slide, this is who I am. Graduated way back in 2006, computer and statistics stream. Did my postgrad from ISB Hyderabad, if you know, from this institute. I do have 14 years of work in data and insights area. I'm very much passionate about data science. So this is what I can think of, like every day in, day out. I could say I think about how we can improve the data science area. Currently working with a leadership role in one of the foreign financial organization in India. Recently got few startups as a mentor who are into data science area. So I'm doing mentorship, helping them into establish data practice in the startups. Prior to this, I was into business and technology consultation also for organizations. So I give a consulting on in terms of how they can enable the digital technology, how they can use the digital technology for their business enablement and on technology front. Okay, so again, I try to capture multiple machine learning definitions from different companies, different people. So these are the good one which I find out. NVIDIA is being a major market player nowadays in deep learning area. So they have a good GPUs which can process your data very fast. So thought of to take their definition into it, and this is that, hey, practice of using algorithms to pass a data, learn from it, and make a determination predictions, right? So this is very simple, right? They are taking the data, they are taking using algorithms, you are passing it, learning from it, and they are trying to predict something, which is NVIDIA says, right? McKinsey's this company. Another the reason is that they come up in other comments which they put it down on NVIDIA's algorithm, NVIDIA definition of machine learning, and they say, hey, machine learning is based on algorithm that can learn from data without relying on rule-based programming, right? Now, other thing came up here is the rule-based programming, right? What does it mean, right? So when we play any very small game, right, it has some rules, right? For example, you are playing any game, any traditional game, right? You will get something on the dice. You play this much amount of numbers, right? It's a very much rule based. This would happen if this would happen, and that way the entire tree data flow. So they are banging up on NVIDIA, NVIDIA's definition and adding few points here and there, right? Then Stanford being with that, Stanford is the first, I think, first university which come up with so much of elaborative, understanding on machine learning and AI, right? And this is it's here. Right. So it says that science of getting computers to act without being explicitly programmed. which I think is more game changer, right? It's saying that without being explicitly programmed, right? For example, any of the web application, right? When you design a website, you have to write something explicitly, right? That your headline should be here, other data should be here, your picture should be here, right? So which is like you're defining something well in advance. But Stanford says no, it's without being defined or without being explicitly programmed. Then Carnegie Mellon, because it's one of the great universities in US, and they are very much active in this area of machine learning. So I thought to capture another definition from there. It says that machine learning seeks to answer the question, right? How we can build a computer that automatically improves with experience, and what are the fundamental laws that govern all learning process. So somehow it's like, mixing up all algorithms are mixing up in each other, right? So definition is definition, we'll see what it is, but I can think of, like, in the last line, you can see that machine learning model learns, identify patterns, and make decisions with minimum intervention from humans, right? Which means they are not using our brain. They are using what they are using. They are using the data which is coming to them. They're trying to learn from them. And then based on that learning, they're trying to make a decision, right? I'm sure you have purchased many things from Amazon, Flipkart, and many more e-commerce sites, right? E-commerce sites, right? You see a recommendation engine which is putting across that, hey, if you have purchased this item, did you forget to buy this also, right? So what it's saying that it's coming from data, right? And it's no human intervention. It's automatically pops up as soon as you buy something on any of the e-com, right? Any questions so far on this slide? Should I take this silence as a no question? Okay. Another thing, right? This is not my teaching philosophy is that I want to have an interactive class, right? If you would ask a question, probably I would try to give it more. So, if you have any questions, I'm happy to answer that. Yep. Okay. Now the Tom Michaud, he is one of the great scientists, which started doing something on a gaming side, and he did a lot of research in the area of machine learning, and he said that a computer program is sad to learn from experience E. So it is something like, I'm rephrasing what we have learned in the previous slide, right? It's saying that now it's going into the more maths than the theoretical information, right? It's said that program is learning from experience E with respect to some class of task T, performance measure P, and its performance at task in T as measured by P improves with the experience E. For example, you are playing a game of chess, maybe, right? And in that chess game, you do a task, you just move some of your like any sort of activity, you are taking an action onto it, right? It checks the performance, whether it's being taken care. Whether this have been considered a good move or it's a bad move, right? And it's saying that is the experience they are talking about based on task T, right? And you are measuring the performance of that move of P as a P, and then based on it improves the experience, right? If your move is wrong, right, probably you're not gonna to get the next move on that. It's thinking from different way. So this is how the entire algorithms of machine learning works. These, I can say, this is the crux of the machine learning, right? The task you are doing in a human nature, right? For any decision you take in your life, you perform some task to take a decision, right? If you think of that as an action from your end, right, you can get a reaction. Either it could be good or it could be bad. If it is a bad, your performance measure is bad. If it's good, your performance measure is good. And based on that, you think of, if your decision is correct, your experience would be good. If your decision is wrong, your experience might be not good, right? And that's how the human human behaves. And on a similar lines, the machine learning algorithm behaves. Can I go on mute? Can you please go on mute? Hello? Hello? Hello, can you please go on mute? I'm just kidding. Great. Now coming to the part of like, hey, why we need a machine learning, right? Things are going good without machine learning also, right? We can take our own decisions. We can do whatever we think of. It might be good, it might be what we will correct it later, right? Maybe you can say that, hey, I open a store, right, and put down my money of say several lakhs of dollars, right, a few millions dollars. You put it down into the store, and you say, hey, whatever is there, I don't care. It's a loss or profit. If it's a profit, it's good. If it's a loss, I can think of again, right? It's a loss, right? It's a loss, which means that you don't get that money back, right? So if you want to take a decision based on data, probably you can get it a much accurate results than anything else, right? So we can say, why we need a machine learning. Currently, I can say healthcare. In the current pandemic, do you think machine learning being used? Yes, we are using machine learning. Every vaccine which is coming into the market being measured on based on efficacy, and the efficacy is being driven from the machine learning, right? They're capturing the data on different peoples. Few of them are being vaccinated with the original vaccine, few of them are being vaccinated with the placebo, and that they're measuring that what is the impact of both, and based on that they get efficacy. They say, hey, this is a control group, this is the original group, this is non-control group. Control group is something like they give a vaccine to those people. Non-control group is something like they didn't give a vaccine, they didn't give a placebo to them. And they say, hey, go ahead, go into the market. They time to time measure their, what's going on. Are they getting infected with the COVID or not? If they are if they are being affected by the COVID, they will come back and see what is the impact, whether that group is being vaccinated with the original vaccine or with the placebo, and based on that they are doing the evaluation, right? So healthcare is I think is a bigger chunk, right? Maybe a medicine, right? You're putting down a medicine into the market, right? You are rolling out a medicine into the market. You have to test that medicine with a group which is different ranges, right? Maybe children's, maybe in adults, maybe on old age peoples, right? So healthcare have a big area. Government, I'm sure you have seen many government are implementing this face-based identification of the criminals, right? That is all coming on from the government end. Marketing and sales. Marketing sales is that who is my person to reach out so that my product sales is high, right? Is being solved through machine learning. Financial services, any fraud detection is coming from the machine learning, right? any trade which is happening wrongly on a stock exchange can be determined from the machine learning, right? You have seen a lot of news in the market that insider trading that can be taken care from the machine learning. You can easily identify it. Oil and gas, it's like a new area which is evolving a lot, right? It's giving you a very hypothesis testing on that. Given the area, whether you will get a oil, you have an area, right? Based on that observation of that area locations, do you have oil there or not? You can get it from machine learning. Manufacturing, I think you know Industry 4.0. Entire assembly line is being changed from machine learning robots with the accuracy close to 99.99%, which means out of 100, out of 1,000, items, only one got be defected. Rest all are okay, which means no manual intervention. Nothing would be done by the people. It can be taken care from the entire assembly line, which is fully automated. Any questions on this slide? Anything you want to talk more? It's just a glimpse what I have written, but happy to talk more if you have any questions. Anyone in the class? No? No questions, the class? Okay. So going to the next slides, what we cover in this course, definitely a probability. I don't know, do you like the probability or not? But yeah, it would be part of curriculum. I will also cover the random variables, the property of the random variables, how it goes. Then coming on to the linear algebra, I'm sure you have learned it. If you are from maths background, you have learned matrix multiplications, eigenvector way back in class 11th or 12th. I'm going to cover that also. I'm going to cover the main heart of this entire machine learning exercise is the stats. So I'm going to cover this both, very much into deep, because once you get this one correct and the hypothesis testing correct, rest all would be a cakewalk for you, a very much cakewalk for you, right? Hypothesis testing, I tried to cover both, R and Python. I don't want to restrict you onto one language, because both language has an advantage, both language has a disadvantage. So I'm going to cover Python and R. It will be revision, not like sitting on every code, every line of code, right? I would cover supervised methods, which includes regression, linear regression, logistic regression. If you wish to do learn more, I can cover more regressions, beta regression, and many things. I would cover SBMs, k nearest neighbor methods, tree methods, and whatever comes into on the way. So I would cover almost all supervised methods. I would cover unsupervised methods, which include clusterings and a priori algorithms. This is sort of a rough course curriculum. If you wish, I can cover deep learning, but given the condition of deep learning, we need a GPU. So let's see how feasible it is. But at least I will give you some glimpse or some sort of scratching the surface part of for deep learning. So I hope you are okay. Now I want to listen at least yes and no from the class.
Yes, sir.
We have only one guy in the team or in the class?
Yes, sir.
Yes, sir.
Great. Getting good response. Thank you. anything you want to, anything you have in your mind, you want to discuss, or you want to say, hey sir, we learned something, this one, do you cover that or not? Do you have anything you want to talk about?
Would we be covering anything related to artificial intelligence?
Okay, so AI is an advanced version, right? I can say machine learning is something like, you created a program, right? You get an output. When you implement that into real-time production, right? And based on that, it started throwing you, or maybe not in production, right? Based on new data, it started giving you an output as a result. It's called AI. So it's like, you can say it's all is AI. All is AI. Makes sense?
Yeah.
Good. Any other question? Okay. Now we think of like, hey, what's the taxonomy of machine learning, right? I'm just giving you some understanding, like how it looks like. So one part is like supervised learning, other part is unsupervised learning, and reinforcement learning. People think of that, hey, they are different bunch, right? I talked about in the last one that, hey, supervised is very different than unsupervised, right? And similarly, I'm going to present it here. Reinforcement learning is again could be a based off deep learning or could be based off the feedback method. So I'll talk about this also in our curriculum. So this is like more or less is needed. If you can cover both them, you can't cover it this one, probably you missed some part of it. So I would cover all three. So what people thinks of that, hey, there are three different part of the word where we have supervised learning, there is unsupervised learning, and third is the reinforcement learning. Unfortunately, it's not right? So they are overlapped with each other, right? Supervised is some sort of overlap with the unsupervised learning, right? Which means sometimes you have to be dependent on unsupervised output to a supervised input, right? And similarly, it goes with reinforcement learning and vice versa, right? So this happens in a day-to-day life. People think of very differently, but they are very much interlinked, right? And it's a very I can say it's a very simplistic view based on different tasks, right? Maybe in a task you have to apply unsupervised learning first, right? And use that output into the supervised learning, and that will throw you some results or some output, right? And you will use that output as an as an end business decision, right? So this can be also viewed as a tool or method. So whatever you can think of. Coming to supervised learning, right? Okay, I'm just trying to give you some context on how the supervised learning looks like, right? I'm looking for a very much response from you also to understand what you are thinking of about it, right? And I think the reason for this is that you try to get some more common sense, right? When you try to implement a machine learning in real time world, probably you can think of from that problem from the real time perspective, right? So, okay, the question to the class is that, hey, I want to predict a house price, right? Maybe in Delhi, maybe in Noida, maybe in Gurgaon, maybe in Mumbai, or maybe anywhere else in the world, right? What are the option or what are the indicator could lead your housing price in terms of money? I'm looking for response from everyone. Please start responding. Okay, I'm rephrasing it again. You want to predict the price of your house where you're living right now, right? And if I were to ask you that, hey, what is the price of your, of your whole house, and you say, hey, it's worth of 50 lakhs rupees, right? What are the parameters you considered that your house price is 50 lakhs, not 10 lakhs or 20 lakhs?
The size of the house,
Absolutely great. Yeah.
locality,
Absolutely. Yeah.
and like
What else?
conveniences, beside like how near things like hospitals and schools and all those things are there.
Amenities. Yes, absolutely.
It is.
Team. I need inputs. It's a very, day-to-day problem, right? Sorry, I lost you. Sorry, I can't hear you. Sorry, can you please? Okay, anyone else? Anyone in the class? All right. What are the size? And consider just a size as a parameter of the price, right? You can consider this price is in any terms. It could be lakhs, 100,000. It doesn't matter, right? So what it is saying, your price is on y-axis. Can you please go on mute? Who is on? Pratibha, can you please mute this? Who is not on?
Narayanan Lokesh is on mute.
Hey, Narayan, can you please go on mute? Narayan, can you please go on mute? Narayan, sorry. Right? Okay. Coming back to this, your price, I draw a graph between the square feet size of your house with respect to the price, right? What you can think of, right? It's gradually increasing. If you increase the square feet or area of your house, your price would go up, right? So based on n samples, I try to draw this graph, and how does it look like, right? So what does it have? For every x means every square feet, there is a price, right? And based on that, you got all observations, right? So it's something like you have n samples, 1 2 3 4 5 6 7 8. This is the x value is 500 based on some value 0.6 or 0.7, right? Then you have again the other samples you have, like which says 500 square feet, but your price is 1.0. For 1000 square feet, your price is 0.7, and for another house which have 1000 square feet, which is, or maybe 1100 square feet, it's like 1.4, and that way I draw this graph, right? So this is how it looks like, right? And you think of, hey, your 15 sample is this, right? So you can see based on square feet, your price is drawn. Now, given this particular problem, and I want to say, hey, given this, that your square feet size of your home is say 2600, what could be the price of your house? What you will do, you will come here, somewhere here, right? And you will go up, right? And you say, hey, this is my sample size looks like. So my price of my house should be around 2.6, right? So what you are doing, based on those 15 samples, you are trying to predict what could be price of your house. Now, there might be a chance that at 2600 square feet, you have a 3 or 4 house, correct? So what you will do, you can do 3 things over here, right? Either you can take an average of those numbers of price, you can take a mode of those price, or you can do a median of these 3 numbers. And that way you can say, hey, based on this, my average price of my house is this, right? Or maybe you can say, hey, based on this, the mode price of my flat or house is this, right? So what we are circling back, based on those observations, we are going back onto the stats. And what we are doing, we are trying to find out the tendency, right? The tendency to identify where my number should fall, right? So based on this task, you can get the X square feet size price of the house which have a X square feet size. This is how. Now, question, based on X equals to 800, can you find out a buy? Yes, you can, because it's showing you some relationship and you pass it on the X value to it, because your house price is a function of your area. The only variable we do have is area. It's a function of the area, hence you can predict the house price at the size of 800 square feet. Right. So what it is showing? It's showing a linear line. I'm sure you have learned this in your 11th and 12th class, where linear line equation is y equals to mx plus c, right? So you draw a line based on those observations, on those values, and you just, what you can do, you can draw a line, a perpendicular line from 800, and you can say, hey, this is my price of my house. Another point, you can say, hey, sir, it's not necessary you can write a, you can draw a straight line. You can draw a polynomial line, right? There could be n number of possibilities where you can draw a line. So we will come on to that. What are the possibilities when we go into that regression part? What are the possibilities? But there are a lot of many solutions possible to get this housing price. But in this one, what we have a price. We have given a square feet area of the houses, given we have a price of it. So based on it, we can predict it. Okay, now again we discuss it, right? That house cannot be a function of just a square feet size, right? It could be function of many more, right? And what could be? It could be your lot size. Maybe you have a two houses together, right? Maybe you have a lot size. I'm representing here on many things, right? Number of bathrooms in your house, number of bedrooms in your house, right? Your locality of your house, and many more variables like that. So these are the features, and based on that, you are trying to predict the price. We generally called this as a label and output. Because we are dealing with supervised learning, if you're dealing with supervised learning, your data must have a label. Because if you don't have a label, which means you are dealing with an unsupervised problem. So there are very much differentiation between supervised and supervised. I will explain it to you. What is that? But biggest thing is that you have a label in your supervised learning methods. While in supervised and unsupervised, you don't have any label, right? Now what you have? Not only you have a one variable of x. In the earlier case, it was square feet area, right? But now we have many more variable for x. So lot size is again coming into the picture. So based that we can say where xi have a size, right? Your floor size, number of bedrooms, and many more like that. So if you have a large variable, right? Floors, lot size, zip code, blah, 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 right? Where we are heading now, we are heading towards linear algebra, matrix multiplication, right? So it would we have a n number of values for x, every x, and that way based on those x, you are trying to predict y. So it would be have some another matrix and the third matrix, and it will goes like. So I want to give you some context on it to understand that they all are very much interlinked. So if you are dealing with any supervised machine learning method, the heart of it is stats and the linear algebra. And we discuss about it in detail, in depth in another lecture. Now coming to the unsupervised learning. So data set contains no label, which means you have only x. Now you can say that I do have a group of houses, right? And I want to predict that, hey, how does it look like? Since you don't have a buy, you can't predict the sales price, right? Or price of your house. You can say how this group looks like, right? So these are the houses. Other is like other is like your townhouse, and this is how represented, right? Second thing, it's a vaguely paused. So we don't have any right goal to define in unsupervised learning, right? We have some vague posed things which we have to come to from the understanding of the data. We have to find out some insights from the data, and based on that we take some decisions, right? So I can give you a very good example of this, right? So I worked with the California earthquake. California is like if you know, California is a big town in like biggest state in US, and they come to us with a problem that before just this pandemic which got started, and they come to us that can you please help us to deploy our ambulances. So they said that this is the data we do have, and the data is sort of call centers data. People call them and says that, hey, there is emergency in this particular chip. Can you send ambulance to our home, right? And they don't have anything. We know the severity of the disease and location. That's it. And based on that, we have to predict, or we have to give them some understanding that where they should put their ambulances, and we got a good go ahead from them that it should be. I mean, we can give you approximation from 2 to 5 miles area. The distance could be 2 to 5 miles. So there have been many constraints around it, and we solved it through unsupervised learning fully, right? Any questions so far in supervised and unsupervised methods, understanding about it? No, yes, maybe. Class, I am looking for response. Please do respond.
Hello, sir. Sir, this California government, which you gave example, this is unsupervised learning
Absolutely, ma'am.
because there is no target, no output is there. There is proximity and no output is there. Is that right?
Absolutely. So they don't know, right? They don't know what to do with that. They say we need to deploy our ambulances where we can reach out to those emergency people as soon as possible, and that's our use case for that.
Okay, sir. Okay, thank you.
So they don't have any specific output with what they're looking for. They're looking for the approximation so that they can handle the emergency cases as soon as possible.
Okay, sir. Thanks.
Yeah, I think someone is also asking question. No questions? Come on, guys. You must have so many questions. That's very new for you, right? If I'm not wrong. Class, any questions? All right, not an issue. Okay, so you understand this one, right? Unsupervised part, right? This is how it draws. Okay, so what you can do with this data, right? You don't have anything. So what you can do a clusters. So you can create a cluster out here, right? Which looks similar, which looks another similarity, and this looks much similar. But that's not the possibilities. This also looks similar because they are in straight line, right? And this is another one which shows a inclined relationship. It's been increasing and it shows flat. So there can be many much possibilities of this, right? So how we can deal with this? We have a lot many algorithms to deal with it. We will talk about it, K-means clustering, mixture of Gaussian, and many more. Another good example, I got it. So I was just searching something with one of my friend, and we came to this one. So it's very much relevant for the medical, right? When you do a discriminate, I'm not saying discriminate is very wrong word, negative word, but I say try to differentiate between different genes, right? And how this gene structure looks like, right? So you can see, hey, this green looks like very much similar, though there have been some issues with in patches, but it's okay, which means it looks like almost same. Similarly, these looks like very much same is all red, which means they have some different genes structure. This looks very much similar. It might got hybrid with this some green part, but yeah, that's okay. This is another gene structure and like that.
Start with C and then C++.
Sorry?
Hello.
Yeah.
Hello.
Hello, yeah.
Hello.
Hello, can you hear me? Hello, can you hear me? All right. There have been some interruption in routine, so it's okay, right? So when you do a clustering of those data, right? So it's automatically finding out, hey, this looks like same one cluster. This is another cluster. This is another cluster, and like that. So this is how you can define the clusters, right? Based on different. So I guess attributes or their features. Based on that, you can do a clustering. Come on. So this is something like I put it down here. It's like Wikipedia is a free encyclopedia, I would say no, it's not an encyclopedia, it's a corpus, right? Because it is have unlabeled data set, right? So what you have a words, and based on that you can define vectors. You have relation, and based on that you can define the directions, right? So get some sense of it, what I'm talking about, right? You have a Italy. So most of the times when it comes to the quizzes, right, it will say, hey, if India is Delhi, then Italy is what, right? So it's coming from word embedding, right? So how you encode the words from their perspectives, right? So if India is Delhi, which means Italy is Rome, because they are talking about their capitals. Similarly, France with Paris and Germany with Berlin. So this is how it works, right? Word embedding is like, you can define the word into vectors, and then you can find out. So word is like Italy is being converted into the vector called in vector, and relationship with the Rome is the direction of that word with the another word. Any questions on this? No? Class, any questions?
What is this vector we are encoding the word into?
Got it, yeah. So when you say word, right? So you are saying that, hey, India is Delhi, right? So what you are saying, India is related to Delhi, which means India word is a vector. So when you do a word embedding, right, you have to get a word as a vector, and then you find out a relationship. So every word is a vector. I'm sure you have learned the vector in class 12th or 11th of yours, right? Vector is kind of what, like, it shows a direction, right? Vector shows a direction, which means you convert every word into a vector, and that the next word would show you direction from one word to other word, right? And that way, this direction shows that, hey, Italy is related to Rome, France related to Paris, Germany related to Berlin. And that way, you can put it down, you can convert a word into vector, and from vector, you can find out direction. Make sense?
Yes, sir.
So these are two libraries for word2vec and globe, which is majorly used for word embedding. We also cover this one when we talk about text analytics. What else I would cover? I will cover deep learning. It's very complex. I would cover a couple of more topics which I feel very much relevant nowadays. In fact, when you appear in your interviews, or appearing for your research, or appearing for anything, right? One is bias variance trade-off. It's a very good. I mean, it's a thought-provoking part. So I'll also cover this one. I'll also cover feature selections. And I'm open for any ML advice if you have any question related to it. I will also cover, broader aspect of ML. Nowadays, you can see a lot of questions being raised on Facebook, on WhatsApp, on Google, on the fairness policy, right? So your models is how much fair are you? So it's sort of, you can say, how you can control the entire, entire machine learning processes by using the fairness in your data, fairness in your outputs of the algorithms. It should not be discriminating with anyone in the world. It should not be discriminating based on gender. It should not be based on your ethnicity. So I try to cover the broader spectrum of this ML because it's very much relevant in today's today's environment, because every company, every person is, facing challenges with this. With that, I'll conclude my class. For today's one, happy to have questions. If you have, I'm happy to discuss point. If you want to discuss, if you want to understand more on any topics, I'm happy to do that. Pratipal sir, ma'am, over to you. Can you hear me? Team, any questions? Sorry, class, any questions?
So what is that deep learning you're talking about?
Okay, sure. So deep learning, you can understand that from the human perspective, right? So you can consider it, hey, you are getting 4 inputs, which is coming one from your eyes, another from your nose, another one from your hand, or one from any other area of your body, right? So based on that, right, you are seeing, say, there is a fire just ahead you, maybe 2 feet away from you, right? And you get all inputs from you. You started getting heat from your skin. You can see from from your eyes, someone is shouting, there is a fire, right? And based on that, what action you would take, right? Which means based on that, you will maybe you come a step away, or you will be step back, or maybe you jump it. You don't know, right? You don't know. So deep learning is very complex methods, especially when it comes to real-time application. I can say, all autonomous cars are based on deep learning. One of the biggest area, I can say, deep learning. Another one is, in government body, I talked about in the very first, few slides. I talked about a government approach, right? All facial recognition is part of deep learning, right? So I think I can say in another terms is that implementing human behavior from machine is sort of deep learning. Makes sense?
Yeah.
Any other question? Any questions? Any other questions? Class.
Hello.
Yes, sir.
So everybody, any questions from sir? Did you get something? आपको कैसा लगा? How it feel? You can unmute and say. आप लोग बोल सकते हैं, please.
Should I go out, sir?
Hello. चलिए, okay, फिर अगर if you don't have any questions, चलो we'll end this session, and I hope कि आप लोगों को पसंद आया होगा, and we will continue with these type of sessions later on, and we'll keep you informed. Thank you, sir. Thank you very much.
I think Narayan have a question. I think. Narayan, do you have any questions?
Hello.
Hello. Sir, one question, this is our understanding, most of people think that machine learning can be done only by BTech students or who are from IT, CS, or they can't, how it is relevant for other streams, one, and how it is relevant for even like finance people, sales people these days, these people are doing data science, AI, ML, how that can be applied by finance people, sales people, other than even BTech students.
Sure, ma'am. I mean, let me start with this is a slide if you can think of, right? I talked about healthcare, right? We always try to identify, or companies try to identify that how effective your medicine is, how effective your vaccine is, right? Nowadays, I think everyone knows, everyone trying to say, hey, every company coming with a COVID vaccine and say, hey, our vaccine is 90% we have a 90% efficacy, right? Why they are coming across with those numbers? Because they are doing machine learning part, right? They are doing a lot of stats, and that's the reason they are saying that, hey, this our vaccine is so much effective. I talked about industry evaluation, right? Industry 4.0. It's fully functional, assembly lines with robots, have close to 100% accuracy in the processing. So they are pretty good, right? Financial services, we are using many things in financial learning, financial space, insurance space. One of the biggest example of this is fraud detection. For example, you have an insurance policy. What are the probability that particular person who's filing for the insurance is a fraud or not, right? Your transaction on your credit card, on debit card, on your net banking, is it fraud or not, right? In financial segment, I can say these are the customers who can you're a person to reach out who can get your loan, right? You're a person who can get onto the who can get your credit card, right? Now coming on the sales part, right? For example, you launch a product, or say you launch a product, right? You want to say that how's the response? You can start sending the samples, and you can take a feedback from them, and you can find out that our product is correct or not. Is it good? Would it get a good good response from the market or not? You can get it from there. So name it, right? Marketing, people are trying to identify now a lot of things in the marketing areas, that how effective your campaign is, right? For any product. So I think every area has a use case. Every area has a use case in machine learning area.
And sir, whether data science, yes, data science we understand is related to machine learning, but what is demand of industry? Whether by doing this course of AI ML, anyone can get a good job, or he needs to do data science as well, some kind of big data, or that is
okay, ma'am, okay, sure. I can redefine it in two ways, right? One is if you are working in big data technologies, that is one area. Another area, if you are working into machine learning, so I would do a machine learning analytics and everything into a data science part, right? And machine learning, AI, and everything into data science. Another one is part of big data, right? So if you're talking about the big data, absolutely, there are a lot of opportunity in the area of big data side. Also, there are many opportunities in data science. I mean, to be very frank, my aim is to get the people in the market so that they can crack the interview. And to be very frank, the interview, when you go for interview for data science, right? Interviewer would not consider you, just on programming. It will also ask you what you did in the machine learning algorithm, right? Try to understand the nitty-gritty, what goes into the algorithm, what is output, how you can tweak that output, and how you treat that output, right? What business value you gave back to business, so that your algorithm was viable by the business. So this is sort of, yeah, I can tell.
And sir, how about application through this course? Like some part of live project will be done, some application part we will be practicing in this course?
Absolutely, ma'am. I do have a lot of real-time data sets to play with. I can definitely, give a snippet of it, data, because the real-time data is close to, 4 or 5 GB, which doesn't make sense, right, for the students. But yeah, I will definitely give a subset of it, and I'll try to ask them that what inside you get it, right? So yeah, definitely, it's part of curriculum.
Okay, sir. Thank you. Anyone has some question? Please ask. Otherwise, we'll close the session. Thank you, sir. Thanks for your valuable time. Thank you. It was very
Thank you,
informative.
everyone. Thank you, class. Thank you, ma'am. Bye-bye.
Bye. Thank you, sir.